Hello, scientists. Today we're going to talk about velocity, specifically average velocity. Average velocity is the change in an object's displacement or its position over a period of time. Another way to say this is that it's the rate at which an object changes position. So we're thinking about objects that are in motion, and we might ask how fast they're moving. Velocity is a little bit like speed, but speed only has a magnitude. It only answers the question, how fast? When we're talking about velocity, we are talking about a number that has both a magnitude and an amount, which is how fast, and it has a direction. So this is similar to like how distance has a magnitude, but displacement has a magnitude, right, and an amount, but also a direction. We might say it's north, south, up, down, east, west, etc. Our equation for velocity follows pretty naturally from this definition. So we are going to have, I'm going to put our variables in first. We'll have V represent velocity. We'll have delta X, which is our change in position. We also know that delta X is displacement, right? That's the same thing. And we have an equation for that. Delta X equals X final minus X initial. Our final position minus our initial position equals our change in position. The final variable that we have for the average velocity equation is delta T, T for time. So this is change in time. And anytime we have a change, we can do final minus initial, sorry. And so we could say that delta T is our final time minus our initial time. T final minus T initial. Okay, so let's put these things into an equation. Our equation is going to be V equals delta X over or divided by delta T. If you're typing, I know this is not great to type, so you could write V equals delta X divided by, right, slash delta T. And that would be fine too. I know I write these kind of funny cursive T's. I promise they're T's. And then another way to write this, if we wanted to fill it in with a little bit more detail, is that we could also write velocity equals X final minus X initial over T final minus T initial. And if you were going to write this out, handwrite this out, I would write V equals X final minus X initial slash T final minus T initial. This is an X, it got a little funny. Because order of operations becomes important. So either of these, any of these equations will work to find our velocity. It sort of just depends on the information we have and also a little bit which one you feel more comfortable with. If you're comfortable with a delta meaning change, that's great. If it's easier for you to separate F and I, final and initial, that's awesome too. Okay, so this becomes a little bit easier as we look at an example. So let's look at our first one. We have Tiki Chelana, an Ethiopian distance runner, and she holds the Olympic record for the fastest women's marathon time, and her time is 2 hours, 18 minutes, and 58 seconds. I'm going to highlight that. I know it's important. So if the marathon is 26.2 miles, what is her average velocity? So 26.2 miles, and then I'm looking at my question, which has average velocity. Okay, so my first step is that I'm going to plug in my variable. So delta X is change in position. So from her starting position to her ending position in the marathon. She went 26.2 miles. And then her time, how long it took her to run that, is 2 hours, 18 minutes, and 58 seconds. That's kind of a crazy multi-unit number. And so I went ahead and did a unit conversion to get that all to 1 unit. And I would encourage you at home to do the same. You could pause and do it right now, or you can do it later as a challenge. So I could convert to any of those 3 units, hours, minutes, or seconds. I'm going to choose to convert to hours. And again, because I went ahead and did this earlier, I know that that amount of time is the same as 2.32 hours. And then velocity is what I'm looking for. I'm going to use my velocity equation from above. So V equals delta X over delta T. And then I'm going to show my work. I'm going to start with my equation. And then I'm going to plug in my numbers. So delta X is 26.2 miles. And delta T is 2.32 hours. And then I'm going to plug that into my calculator to find my answer. So the fraction bar is division. So I'm going to do 26.2 divided by 2.32. And that comes out to be 11.29. I'm rounding. And then I need a unit with that. And my unit is right here in my equation. So miles over hours or miles per hour. That's that rate language, per hour. So miles per hour. Traditionally, we write this division line to mean per, but of course, if you wanted to do MPH, miles per hour, we're familiar with that. And then I would write my answer in a full sentence, which for the sake of time, I'm not going to do, but I'll tell you what it is, right? Tiki ran her marathon in 11.29 miles per hour, or she ran it with an average velocity of 11.29 miles per hour. In this case, this is not great form, but I don't know what direction she ran in. I don't know where this marathon was, where the course was. And so I don't have a direction to write in. Technically, this is speed, I guess. Average speed, but no, traditionally you would write a direction, right? She ran west. It's also average velocity because I don't think that she ran 11.29 miles per hour for the whole marathon, right? Sometimes she probably went faster, sometimes she probably went slower, but over this distance, over this period of time, on average, she ran 11.29 miles per hour. Pretty impressive. Okay, our next example is slightly more complicated. Here we have Usain Bolt, who's a Jamaican sprinter, and he holds the world record for the 100-meter dash. And if his average velocity was 10.4 meters per second, how long did it take him to run the race? So here my variables are a little different. My distance, or my displacement, sorry, is 100 meters. I'm looking for the time, and my average velocity is 10.4 meters per second. So I have a couple of choices here. I could use my regular equation, and I could just leave delta t out, leave it as a variable. Or I could rearrange my equation. So I'm going to come down here. Right now my equation is v equals delta x over delta t. And so one thing that I can do is I can treat this just like any other algebra equation. I can multiply both sides by delta t, right? And then these cross out. And that leaves me with an equation that I'm going to flip it around, right? Delta x equals delta t times v. So that would let me solve for delta x, but I really want delta t. So I'm going to come back over here, and I'm going to divide both sides by the velocity, right? These cross out. And then I write my new equation, delta t equals delta x over v. And that's really the equation I want to use, right? Where I have delta t, the variable I'm looking for, on one side, and then delta x over v on the other side, so I can plug in there. So let me come up here. So that was delta t equals delta x over v. Okay, then we can look at this. So delta t equals delta x over v. And then I'm going to plug in 100 meters over 10.4 meters per second. I'm going to plug that into my calculator. So 100 divided by 10.4, and I come out with 9.6. Okay, my units are a little complicated here. My unit is not meters per second. Because I have the seconds that's under 2 fraction bars, I'm gonna write this in a different color just so you know it's different. This is the same thing as saying 100 meters and then 10.4 meters per 1 second. Right, that looks just like a unit conversion. This means the same thing mathematically. And so in this case, right, I know automatically I'm going to cross out my meters and I'm left with seconds as my unit. And it's delta t, right? That's a time. That should be in time units, right? Like seconds. So 9.6 seconds. And then to answer my question in a full sentence, I would say Usain Bolt ran the 100-meter dash in 9.6 seconds. Okay. I want to write these 3 equations for you just a little bit neater so you have them to pull from. And again, I would pick the one, when you're reading your problem, pick the one that you're looking for to be on the left-hand side. So we have V equals delta X over delta T. We have delta X equals V times delta T. And we have delta T equals delta X over V. So if I'm looking for velocity, I use this one. If I'm looking for the displacement, I would use this one. And if I'm looking for the change in time, I would use this one. And that just keeps things a little bit simpler for you. You can, of course, rearrange the equations, but now you just have them to pull from. Okay, we'll go over this more in class, but here's the preview of our notes, and I'll see you all soon.